This video, we're going to find volume while using partial fractions. So let's get started. Find the volume generated by revolving the area bounded by y equals 1 over x cubed plus 7x squared plus 12x, x equals 2, x equals 7, and y equals 0 about the y-axis. So the first thing that we always do is to go to Desmos and graph our function. And so this function is a typical rational function, and this red curve here looks like a rational function. The only part of the function we are interested in is between x equals 2, which is this vertical blue line, and x equals 7, which is this vertical green line. So the graph is asymptotic to the x-axis at this point. As we get really, really close, we can see that the curve is getting closer and closer to the x-axis, but it will not touch or cross the x-axis within the bounds of integration between 2 and 7. So let's create a little sketch of this. And so the curve is going to be coming down something like this, getting really, really close between 2 and 7. And we are revolving around the y-axis. So if this is the region and we're revolving it around the y-axis, it would look as though cylindrical shells would be the preferred method. Because if we create a representative rectangle in this region, remember that the height of the rectangle must be parallel to the axis of rotation. So the height of the rectangle is vertical, which is parallel to the y-axis. And the width of the rectangle is along the x-axis, so we will be integrating with respect to x. The formula for cylindrical shells, volume equals the integral from a to b, 2 pi x f of x dx, where x represents the radius of any individual shell, and f of x represents the height of any individual shell. Therefore, volume is 2 pi times the integral from 2 to 7 of x times 1 over x to the 7th, x cubed, times 7x squared plus 12x dx. Multiplying this through by x, we can simplify that a little bit by canceling out some of those x's. And we end up with the function 1 over x squared plus 7x plus 12 dx. Well, this is nice because that denominator is easily factorable. And so this is where the partial fraction decomposition comes into place. So let's do that right over here. So we have 1 over x squared plus 7x plus 12. That will factor into x plus 3 times x plus 4. So we can create two fractions, a over x plus 3 plus b over x plus 4. Multiplying both sides by the least common denominator. Now the least common denominator is always going to be the denominator on the left-hand side, which is x squared plus 7x plus 12. But we don't want to really multiply it in that form. We want to multiply it in the form, its factored form. So when we multiply it, both sides, we're going to end up with 1 is equal to a times x plus 4 plus b times x plus 3. Multiplying this out, we have 1 is equal to ax plus 4a, plus bx plus 3b. Now, equating coefficients, we have no x term, so we essentially have 0 x's will be equal to ax plus bx, or x, or rather 0 is equal to a plus b. Likewise, we have 1 is equal to 4a plus 3b. And bringing this over here, 0 equals a plus b, we have our system of equations. The easiest way to solve this, I would think, is to multiply both sides of the second equation, let's say by -3. That gives me 1 equals 4a plus 3b. And the second equation is 0 equals -3a minus 3b. And when we add these two equations together, we get 1 is equal to a. Well, if 1 is equal to a and a plus b equals 0, that means b must be equal to -1. So that is enough to put together our new integral. We now have the integral of 1 over x plus 4. Well, let me make sure I had that right. Oh, that was x plus 3. So yep, that should be x plus 3. X plus 3 minus 1 over x plus 4 dx. And this is from 2 to 7, and the whole thing is times 2 pi. Let's break this into two separate problems. We will have volume is equal to 2 pi times the integral from 2 to 7 of dx over x plus 3 minus 2 pi times the integral from 2 to 7 of dx over x plus 4. Then, integrating it. This looks like the log rule. So we're going to have volume is equal to 2 pi times the log of the absolute value of x plus 3 minus the log of the absolute value of x plus 4, all evaluated from 2 to 7. And when we evaluate this, and once again, as I do in most of my videos, I will leave it up to you to evaluate this integral. Use Desmos. Using Desmos, you should find that the approximate area is going to be 0.547. So this is an example of finding volume. So it's a good review of the various techniques for finding volume, the disk method, the cylindrical shells, the washer method. You have to select which method would be the most appropriate method to use. And then you never know what type of technique of integration is going to come up. In this particular one, we needed to use partial fractions. All right, hopefully that was helpful. See you in class.